My name is Neha, and I'm part of Team 38 along with Shrathika, and we're Product Care Insights. Our product is DC, standing for Discharge Coordination. So we have a patient, Mary. Mary is a 60-year-old with history of heart failure, CAD, COPD, coming in for heart failure exacerbation. She initially is admitted and getting all the medical tests and treatments. And afterwards, she's medically cleared for discharge. This is when physical therapy is involved and recommends a skilled nursing facility. However, this takes a while to coordinate with social worker, case management, and patient trying to find the right SNF. And Mary's pretty unhappy with the wait time. So we're trying to address the problem, delayed discharges. The cost of delayed discharges is pretty significant, accounting for about 2.5 million per year for patients and also 21% of inpatient stay. So our solution is creating a machine learning model to predict disposition. When Mary is admitted early on, based on her characteristics and presentation, we'll use a machine learning algorithm to determine her placement, in this case a SNF. And this gets physical therapy, social worker, and case management involved early on to coordinate a faster and safer disposition, reducing delayed discharges.
Our solution is to use machine learning to predict disposition. So here, we start off by first retrieving acute inpatient data from Tuva Health. We then explore the data and perform some feature engineering, including imputation, one-hot encoding, and an oversampling technique to account for the class imbalance. We then prepared the data by splitting it into a train and test set, and then we started building our models. We then later scored all of our models and evaluated our models using metrics like F1 score, recall, precision, and accuracy. So we were provided a variety of data from Tuva Health, but we leveraged the following types of data to use in our model. And so that included patient demographics such as age, gender, and race, and some medical history and comorbidities, including admission information, and lastly, functional status, such as length of stay. So here we have the evaluation of all of our models. We use 4 different types of models, including logistic regression, XGBoost, light GBM, and random forest. We achieved an average AUC of 0.8 across all these models. And this is pretty good, as the closer it is to 1, the more accurate the model is. And so lastly, our models exhibit promising potential for accurately classifying appropriate discharge disposition. However, we aim to incorporate additional factors in the future, such as frailty score, comorbidities, and the availability of social support so that we can better achieve a comprehensive and holistic prediction. And thanks so much for listening to our presentation.